study other type of behavior, okay, related to tips, you may want to check out the other columns. But for this, for the purpose of our, what we are doing now, so we only care about the tip and the day, okay. And interestingly, they only collect this data from 4 days, okay, of the week: Thursday, Saturday, Friday, Saturday, and Sunday, okay. So you can see there are only 4 groups, okay. If you just use the just output this 4 group of the data, okay, by using the day and the tip, okay, and you can generate what we call variant plot. Okay, it looks like this. And by the way, the reason why the study only care about these 4 days, obviously, is because Thursday is a typical weekdays, right? It's a typical weekdays. I mean, just like a Monday, Tuesday, and Wednesday. Okay, Thursday is just one typical like weekdays. I mean, you don't have to collect every weekday. Okay, just Thursday should be enough. And the Friday happened to be the, what should I say, like in between the weekday and the weekend, right? So something will be different, okay? It must be different, like on Friday. Saturday, Saturday sits completely inside the weekend, right? And for Sunday, okay, well, because Monday is a weekday, okay, so a lot of people do not go out for dinner, okay, so the tipping pattern will change, okay, on Sunday. The tipping pattern between Saturday and the Sunday, a lot of times different. Okay, so the reason to collect just these 4, the tipping pattern, or just for these 4 days, there's a reason behind that. Okay, you don't have to draw the variant plot, obviously. I mean, but this is just one way to represent the data. Okay, so now, okay, we have we can simplify things. Okay, we can create 3 variables. The y variable, okay, y variable represent the tips, okay, and the idx represent the categorical variable, okay, which encode the days with numbers. For example, okay, this idx, okay, is 0, 1, 2, 3, okay, which represent Thursday, Friday, Saturday, and Sunday, okay, respectively. Okay, so 0 represent Thursday, 1 represent Friday, and so on. Okay, so finally the group variable, okay, with the number of groups. Okay, so we have these 3 things. Okay, so yeah, I mean, here we just define these features. Okay, that's it. Okay, and then okay, we are going to create a model for this problem. Okay, this model is almost identical to the model G. What is model G, by the way? It is a model we use for that chemical shift. Remember? I mean the first one. Okay, not the one before the student's T distribution. Okay, so it looks it looks like we have like normal distribution. Okay, which y is distributed as a normal distribution, And because it's normal distribution, so we have like mu and sigma, right? So so mu, okay, you know, is distributed as a normal distribution, okay, and with standard deviation 10. Sigma is distributed as half normal, okay, with standard deviation 10. So here, okay, it's to be honest, I mean, there are still something that's different, okay, in this model, because if you look at the model G, you remember that for mu we use not normal distribution. We use uniform distribution. Okay, in between 40 and 70, if I remember correctly, right? But now we use normal distribution, okay, to represent the prior of mu, okay, and we set its mu and the standard deviation as a 0 and a 10, okay. So we have changed something here, okay, and then the other part, I mean, are kind of similar, okay, and then we just generate the trace, okay. We call this model like comparing groups, and the trace is CG, okay, comparing group, okay, previous comparing group. So we generate like 5,000 samples. So this sample is larger, okay, 5 times larger than the samples that we collect previously, okay, and then we plot the trace, okay. So the result looks like this. Okay, the posterior of mu, okay. Keep in mind, we have 4 groups, right? So we have 4 mu's, okay. Mu 0, mu 1, mu 2, and mu 3. Mu 0 represent the mu for the Thursday tips, okay. Mu 1 represent the mean of like Friday tips, okay, and so on, okay. So you can see they are slightly different, right? It looks like Sunday's tip is higher, right? Sunday's tip is higher. So, but anyway, and this is sigma, okay. Again, we have 4 different sigma: sigma 0, sigma 1, sigma 2, and sigma 3. Okay, and they obviously have, you know, distributed quite differently. Okay, and then, okay, the most important thing is generating this is just like the previous one. I mean, we have these 4 groups. The only difference, I mean, compared with the previous example is now we have 4 groups. So we generate the mu and sigma for these 4 groups. Okay, but the more important thing is that we want to plot the differences. Okay, the differences. So this code is just a way of plotting the difference without repeating the comparison. Okay, so instead of plotting the all against all matrix, we just plot the upper triangle portion. What do we mean? Okay, so we want to see, because for 4 groups, let's say group 1, group 2, group 3, group 4. Sorry, we have group 0, group 1, 2. Group 0, group 1, group 2, group 3, right? And you could do the comparison. If it's like, if you consider all by all against all, then it's a 4 times 4, right? So you have like a 16 blanks, okay, like 16 pairs to compare. But you know, like out of them, like you don't compare with yourself, right? So the diagonal is gone. Diagonal is gone. You don't compare like one model against itself, so don't do that. And this metric obviously is symmetric, so you don't need to you know, if you have this, you don't need this, right? So you only need like the top triangle, okay? That's what we meant, okay? So this piece of code, just do this, okay? I will not go into the detail like line by line, but the result is something like this. So the first one is mu0 minus mu1. The second one is mu0 minus mu2. The third one is mu0 minus mu3. And then mu1 minus mu2. Mu1 minus mu3. And then mu2 minus mu3. Okay, so we have 6. Okay, that's good enough. Because originally we have 16, right? Getting rid of the the diagonal, we have 12. Okay, and we only need half of them, so we have 6. Okay? So we are able to output like the difference of the mean, okay, in terms of posterior distribution. Okay? And then in here we also mark the reference value, which is 0, because when we subtract one mean from another, if the difference is 0, that means they are similar, right? There's not much difference between the two groups, right? So first we can observe, like if this reference value is inside their 94% HPD, okay? So you can see that, okay? Well, out of these 6 results, the only one that, the 0 does not, this zero reference value does not fall inside the 94% HPD is this one, right? What is this one? This was mu0 minus mu3. So Thursday and Sunday, okay, these two groups are the most different one. Okay, you can probably say that. Okay, this is based on, this one, posterior plot with a reference value. I already show you, okay, with a reference value 0, okay, you can claim that like the Thursday's tip is significant, is lower than the Sunday's tip. Okay. So, so the difference in tips between Thursday and Sunday. So for all the other example, we cannot rule out a difference of 0, okay? Because the difference the 0 is still inside the 94% HPD. So even for that case, okay, it's an average difference of $0.5, large enough, okay? So is that difference enough to accept working on Sunday, missing the opportunity to spend time with family, okay? Is that difference enough to justify averaging the tip over the 4 days and giving every waitress and waiter the same amount of tips money. Okay, sometimes this is the practice of the restaurant. Okay, it depends on the restaurant. Some restaurant, okay, for example, like if a customer gives tip for to a particular attendant, okay, then that attendant, okay, either waiter or waitress will just collect that money at the end of the day, okay, from the restaurant, okay. But sometimes, okay, sometimes, like the restaurant will collect all the tips and distribute evenly to all the waiter or waitresses, okay. It's just because like some restaurant, like the business model, okay, for the waiter waitress are more kind of like a cooperative. They work cooperatively, and so it's difficult to tell. Like this service is just this service. I mean, comes from a particular waiter or waitress. Okay, sometimes. Okay, so this is like it depends on how the restaurant like decide like this policy. Okay. Or, okay, those type of questions, okay, cannot be answered by statistics. They can only be informed by statistics. So the statistic result okay, help the maybe like people to make decision, but the decision is still made by people, not by the this statistics result. Okay. And then, okay, the interesting part is here, okay? The next topic, okay, this topic is much more interesting, okay? It's a hierarchical model, okay? Suppose we want to analyze the quality of water in a city, okay? We take samples by dividing the city into neighborhoods. So we may think we have two options to analyze this data. The first one is we study